Hello, class. Right now, we're going to start going over lesson 1.2, how to understand rational numbers. So I want you guys to start out with a little exercise today. I won't go over this, but I would like you to start off by listing 5 integers and their opposites. Remember, an opposite integer are 2 integers that share the same distance from 0, or they share the same absolute value. All right, so let's start with the definition here. So additive inverse. Additive inverse are 2 numbers that have a sum of 0. So for example, -1 plus 1 sum to 0, -5 plus 5 equals 0, and -1,000 plus 1,000 equals 0. So all of these numbers would be additive inverses. Next, we have that of a rational number. A rational number is a number that can be expressed as a quotient or fractions of 2 integers where the denominator is non-zero. So these are obviously like common fractions like you're used to, like such as 3/5, 1/2, 2.25, 1 and 1/5, or 2.3. So we see here that fractions are included, but we also include decimals. And the reason is because we can rewrite decimals as fractions. For example, this could become 2 and 1/4. No point, my apologies. 2 and 1/4. And 2.3 can become 2 and 3/10. All right, so let's first talk about how can we relate additive inverses and opposite integers. They're basically the same. Remember when I told you that 2 numbers are opposite integers but they share the same distance from 0, such as -1 and 1? Well, let's look what happened if we add these together. -1 plus 1 would be equal to 0. So obviously if 2 numbers are additive inverses, then they are also opposite integers. All right, a repeating decimal is a rational number whose decimal place does not stop, but repeats the same numbers. So I want to make sure you guys get this down in your notebooks. So if we're looking at something like this here, when we have a number that looks like 3.333, and then this goes on forever, then we could write that as 3.3 with a little line over this here, and we would call that 3.3 continuing. We could also do that for more than one number here, right? So for example, this one here, I have 2.25, and the 2.25 just keeps going on and on forever, right? There should be some dots here to let you show this goes on forever. But we just write it like that, 2.25 with a line over your digits that are repeating. And it could happen with as many digits as you want here. If we look at this number, we repeat all the way up to the 3, right? It says 1, 7, 8, 9, 5, 6, 2, 3, 1, 7, 8, 9, 5, 6, 2, 3, and this will go on forever, right? So I would write it like this, 17.17895623 with the line over those numbers there. Already, one last one for us here is a terminating decimal. A terminating decimal is a rational number whose decimal place does not repeat but stop. So like, for example, any decimal you're familiar with, 2.1, 2.25, 100.7, yada, yada, yada. All of these work. Alrighty, so how to find decimal form from fractions. So giving a fraction, we're going to use long division. So for example, 51 over 12. Well, first off, I'm going to break this into a smaller number here. Remember, this is a mixed number, so I'm going to break this down into a easier number here. So I know already that 12 goes into 51 4 times, because 12 times 4 is 48, and then we would have a remainder of 3. So I have 4 and 3 12s. Now all I have to do is go over here and do some long division. So we will do 3, and we're going to divide that number by 12. All right, so how many times does 12 go into 3? It doesn't, right? So what we're going to do is we're going to put a decimal right here, as well as above the number line. We're going to say it goes in 0 times. We're going to add another 0 right here, because remember, you could add in as many as many zeros after this decimal point as you want, because it doesn't change the number. And now we're going to do a division. So how many times does 12 go into 30? Well, I know for starters, it would go in 2 times. We would get a 24. Now I'm going to bring down a 6 because 30 minus 24 is 6. I'm going to add in another 0 here, and then I'm going to bring it down. Now we have to ask ourselves, how many times does 12 go into 60? Well, 12 should go into 65 times here. 12 times 5 is exactly 60. So now we have no remainder. So that shows us that our decimal point here would be 0.25, or I could write this as 4.25. Oops. Alrighty, a couple more examples for us here. A poll is taken and 28 out of 100 students agree that the school menu should change. How can we write this as a fraction in decimal form? 28 over 100. All right, so again, we could go to long division here. So I'm going to simplify it first. I know 28 is divisible by 2. I'm going to call that 14 over 50. These are also divisible by 2 here. So 14 divided by 2 is 7. And we're going to